Hey guys, what's going on? George here from APG. Today we've got a fun video for you. You've kind of been a part of the process all along. You've seen some of the cars that we've built. You've seen the completed details, and you've seen the end results. But those details along the way of how we got from that concept and to that finished produced part, we feel that it's important for us to do a series of educational videos showing you how we do what we do. Now, when you compare our products versus another company's products, we want you to have the knowledge and the understanding of why our products are made the way that we do make them and why others follow a different set of manufacturing processes. Now, these manufacturing processes that we're going to define here are not meant to insult other companies or to bash on them. We just want our customers to know not just why, but how we make our parts the way that we do and how the other companies make their parts. Then we can talk about price points, advantages and disadvantages of the individual manufacturing products. And based on these proven mechanical breakdowns of processes along the way, that you can make an informed decision of which route is better for you. We're gonna take you through the manufacturing process that a lot of other companies follow to make a external fender or flare or hood or something else. We're gonna show you how they make their parts. But we are just going to assume we have two different molds that are perfect, and how are you gonna pull a part off of that mold? The process that each of you in the aftermarket off-road and some on-road industry customers see is fiberglass. Fiberglass, fiberglass, fiberglass. You see it all the time, $1,000 body kit, takes 10 minutes to make a part, great. But you're gonna have problems, and I'm gonna say that on record, you're gonna have problems. There is no way to create a repeatable manufacturing process that takes 10 minutes to produce a part that is going to last with the expectations that you expect. So, how are we gonna make this part? Step one, heavily gel coat your product to create that perfect contour and that perfect first layer against your mold surface. And that is a critical point that we really wanna get into. They are not spraying in a primer, they're spraying in a gel coat. They are spraying in a gel coat because they wanna create a perfect appearing product. Step two, you're gonna grab some of your slurry mix and you're gonna start filling some of the sharp corners, peaks and valleys to kind of flood that in. You're gonna create that secondary layer on top of the surface coat, and then you're gonna start laminating your fiberglass. Mix up your polyester resin. So you got your resin, you got your MEKP hardener, you're gonna mix it up, and then you're gonna start whether wet coating that on, or you're gonna get some fabric and you're gonna start rolling that fabric along, take some large sheets, place them down, and for the most part, you're following a very uncontrolled manufacturing process. You're not controlling the resin to fiber ratio, you're not compacting it, you're not ensuring your material is overlapped correctly, you really have no way of controlling thickness. And then if you're just lucky, that fiberglass manufacturer will apply a true layer of fiberglass material. Most of the fiberglass you see is a chopped strand material. A lot of fiberglass manufacturers like to work with this. This has very little tensile strength. It just tears right in half. They use this because they can tear it, shove it into corners, and it's malleable and it reduces the chance of bridging on the parts. But this stuff is weak. It has no tensile strength. I know I shouldn't have touched that with my hands without a mask, in case you guys are thinking that. Now we're gonna show you what happens when you pop the part. I'm gonna jump in, we're gonna pop this part, and you're gonna see the defects that are hidden by a gel coat and or what your actual part, if you have a fiberglass body kit, what it looks like underneath that paint and gel coat right now. All right, we got a part. Now, let's show you the real part. We've got two sides to this part. We've got our coated surface, and then we've got our surface where we can apply any surface coat, gel coat, or I call it makeup for a part. It's just a raw, wet laid fiberglass part. So I'm bringing it in close. Each of these lighter areas are air pockets, air voids. Air is the devil when it comes to composite manufacturing. Look at this. When you see the darker areas, that's resin-rich, where it's like a pool of resin and not interweaved into the glass fibers. Corners and peaks and valleys are where you typically see the worst issues. But I mean, on this part, I would estimate there's at least 5,000 air pockets. Gel coat's gonna hide all that. Look how perfect this surface is. You don't see any of these defects, but they're there still. We only surface coated half of the part. The other half of the part was left open so we can show you guys what your part looks like underneath. That's the problem. This is an absolute big problem. You don't want that underneath your paint. You don't want that underneath your surface, because this is going to eventually work its way to the surface and create defects in your part. So the theory we're trying to get across is, if you're manufacturing a quality component, you should not need a surface coat, because the surface coat is hiding the defect. What are my options, right? Your options are advanced composites. You're not going to stamp an automotive body panel to make 100 sets of something. We park our investment into our engineering, into our tooling, and our part manufacturing process. Therefore, the refinishing and the installation costs down the road are half, and you have a product that lasts like a factory stamp body panel. It's super clear for us, but we needed to show you how everything else is done so you can get an understanding. All right, guys, we are now inside of APG's composite shop. Now I'm going to take you through the manufacturing process, just one of our manufacturing processes, how we take our product from a raw material all the way up to a completed product installed to the car. Step one, templating. Pull the carbon off the roll. We are a low volume manufacturing facility, so we hand template everything. That makes us very agile. Plus, we're using some newer electric scissors these days that are, you know, cutting with great speed. And then once we get everything taped and marked, we're even gonna apply some composite grade spray adhesive. This is going to ensure that when we cut the carbon, we have a good crisp cut edge. Now we only do that on the first ply, but what we don't wanna see is an ugly trim on the outside, because that's gonna result in a poor cosmetic finish on your exposed carbon fiber part. So getting the adhesive down, carefully cutting the first ply, that's what's gonna get us those perfect finish results down the line. We're gonna go straight into a prep tool and show you how to get these parts laminated. All right, guys, we're standing in front of a fender flare tool. This is a very basic shape. It's easier for video demonstration purposes, but we have a lot of complex shapes. In order to get the material down to hold into position before we get the bag on it later down the line, we'll utilize some spray adhesive. This spray adhesive is different than any spray adhesive you get from Home Depot, except this is a composites grade spray adhesive. So as soon as it hits certain temperatures, it's gonna dissipate, and it's not gonna leave any residue and or contaminate the part in between the different materials. So I'm not actually gonna do this, this part is mid-production, but the laminator is gonna get in, they're gonna spray some adhesive, let it tack down, and they're gonna start getting the plies and carefully getting those plies deep into the mold. Now, this is the first ply going down against the surface of the mold is the most important step. Getting the first ply down is the cosmetics. Laminators are gonna place the material in the mold, followed up by secondary, third, sometimes four plies, depending on the part, shape, and geometry. Once we get all the actual carbon fiber dry laminated into the mold, it'll be inspected by the manager, then shifted over to station number 2, and we'll show you that next. All right, guys, we're on to stage 2 of our composite manufacturing process. This is the release and consumable section. So carbon's all laminated inside the tool. The next material that's gonna go directly against the inside surface of the carbon fiber is this release film. This is a silicone coated release film. It will get applied to the surface using a more cost-effective 3M spray adhesive. Doesn't matter, it's the inside of a part. We don't have to worry about contaminants on a surface down the line. A lot of things are thought about in the background. Get the spray adhesive down, let it tack up, get your release film. This is a porous surface that allows resin to transfer in to saturate the surface of the carbon fiber. And as soon as you get that down, you have to think, how is the resin gonna travel through the part? In comes our next material. This is our flow material. So we will place this release agent, then this against it, and then bag over the top of that. So as soon as we are done with our infusion, we will pull back on this release film, it'll remove the flow agent, and we're left with the back side of the part. Now we're gonna get into the next step, which is hoses, more release agents, and vacuum ports. All right, so now I've got a part on the third stage of this manufacturing process. Now we need to do the prep for the infusion and the vacuum process. So take a look at this 1/4 inch 3/8 line right here. This is our injection line. This hose is gonna feed right into the injection port. It's gonna insert into the bagging region. It's gonna route all the way down side A of the surface, wrapped up next to that green flow media that I was showing you about in the earlier step. Now this is our vacuum port. It's on the other side of the component. This is gonna be a cross bridge infusion. It's gonna go from the top side, run across the part surface up to the other side. So now we're gonna get into bagging. So we will not spend much time into the bagging, but for the most part, we use a closed bagging process. all of our parts before the resin is injected. We will pull off a various bag length, measure across the table, apply our application film, the tacky tape, and we will either surface bag or envelope bag every single part. Now, this is gonna be a surface bag. Certain parts will require an envelope that goes over the entire part, but this is a surface bag. It'll get bagged where this green line is. We have some tape applied there, so it's clean, so we pull it, and then the tacky tape will apply and have good adhesion properties. So we will surface bag, draw vacuum, suck all atmospheric pressure and air out of that closed contained laminate, and let that sit overnight. Bag's gonna go down. We're gonna shift over here to the actual debulking and infusion section, and this will be one of the final stages of the actual lamination process. All right, so now we got the bag down. So you'll notice right now, we've already extracted air from the containment of this lamination system. This is our injection port. This is our vacuum port. This part is gonna sit overnight following a debulking process, pushing everything into the corners, getting thin, getting lean. All right, so the next morning we come in after the debulk, and the last step before infusing or injecting is gonna be the leak test check. We will run a 20-minute leak check, making sure we're not getting any drop in vacuum. If these do not pass our rigorous leak check specifications, we will stop the injection process, pull the bag, and start back at stage 3 again. That's essential. So now we've got the leak check done. This part's ready to be juiced. Let's bring it over to the infusion side over here. All right, so now we're gonna start infusing some parts. We use an epoxy resin system here. Everything is a high temperature, 300 Fahrenheit and above. So it's a 2-part formula. You've got your epoxy and you've got your epoxy hardener. It is carefully measured on the scale. It's mixed up, triple cup mixed, reweighed, and then goes into our degassing chamber. After degassing, it's gonna go into the infusion. We simply pour them in the pots down below. There's already vacuum applied inside of this laminate. So in order to get the resin to flow, all we do is simply remove the clamp from the injection port, and the vacuum that's already connected inside the laminate is going to draw that resin in. We are going to monitor vacuum pressure throughout that process. There's so much science in the steps that I'm missing along the way, but you're kind of getting the point. But that infusion process, that closed bag, closed cell setup, infusing across the face of the panel, under vacuum, protected, consistent flow of saturation is how we're getting these perfect surface quality results. It's gonna ensure your bodywork and your paintwork lasts for years to come. All right, so we've infused. That part is now sat up. Once you let it sit up for 24 to 48 hours, depending on the part shape and the resin system, you pop the part. And this is a part directly out of the mold. You can tell because it has not been trimmed yet. This part is awaiting post-cure. So the parts will sit up with a slight increase, about 140 Fahrenheit, just to get it, just to reach some temperature stability so we can do a freestanding post-cure to free up the molds. But look at that surface quality. I would consider this a perfect part, but we're not done yet. This part needs to be post-cured. I'm gonna have you pan into the oven. You're standing inside our 21-foot tall, beautiful JPW oven. This is a large curing chamber. This curing chamber can go up to 600 degrees Fahrenheit, but for the most part, we like it because it's efficient. We can load several layers of parts and run a 24-hour cure cycle. All right, temperature control inside of the parts. It's not just about leaving things in the sun, it's about applying heat in a controlled state. We need the oven, this curing chamber, to follow a temperature curing profile that this resin system, in combination with the reinforcement system, wants to see. Typically, it's 20 degrees Fahrenheit, ramp up per 60 minutes, up to 280 degrees Fahrenheit. Hold that for about 8 hours, and then slowly cool down to ambient temperature, 80, 90, 100 degrees, whatever it happens to be. Once that oven cure cycle is complete, you've now finished all the composite manufacturing process. All right, guys, we have went through the composite shop. Now, you've only seen a small taste of what we do here. That is just one part manufacturing one set of processes. Now, comparing it to what you see in the industry via wet lay fiberglass, I think we've done a good job defining the differences between these two different manufacturing processes. Now, following our list of manufacturing processes is how we are able to achieve the results that we get. There are not many other low volume manufacturing methods that get you the temperature stability, the resin to fiber ratio, and the mechanical integrity of an external body panel. So we are left with a part that is the intended shape of what our engineers wanted. So several different shapes, several different tools, several different processes. We felt it important to show you guys how we make our parts and what we know you will get as a result after going through the process with us. So we're gonna spend more time in the composite shop going through different processes, different stages of it. We're gonna take you to trimming. We wanna take you into the refinishing process that we follow. Everything from our pre-primer process to how to refinish exposed carbon fiber. We're gonna spend some time in our beautiful 26-foot downdraft paint booth and just getting a lot more behind the scenes footage. I'm very passionate about what I do. I have got an amazing build facility. We've got such an enthusiastic team here. We are very passionate about the work we put into your guys' cars. So I want to continue to bring this content to you guys. Just drive it home and have a good time. I hope to see you guys on the next video. If you do want to see those different videos I was talking to you about, hit the subscribe button and follow along for more.